Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland. And this short video, another video dealing in our series of videos dealing with logarithms, and another video dealing with the evaluation of logarithmic expressions is going to consider another couple of small examples. Okay, so what we'd like to do is, let's say example one. Let's call this C1 here. Okay, what we'd like to do is to evaluate the logarithmic expression log of the square root of 27 to the base 3. So we'd like to evaluate this. What does this work out as if that makes sense? Okay. So let's just assume we know the answer, and let's say the answer is x. So let's say we have let log of the square root of 27 to the base 3. Let that equal x. Let it equal some value. And what does this mean from our definition of logarithms? Well, what this basically means is that 3 to the power of x must be equal to the square root of 27. So this implies that 3 to the power of x must be equal to the square root of 27. Okay. Now, I suppose if we put this in the form where the power is in fractional notation, this implies that 3 to the power of x is equal to 27 to the power of a half. Yeah, and that's what it means. The square root is, by definition, a number, the base raised to the power of a half. That's what it means by the square root. Okay, but let's think about 27. 27 can be written in a form in a form of powers of 3. So this implies that 3 to the power of x is equal to, well, 27 is just 3 to the power of 3. So this is 3 cubed, that's 27, which needs to be raised to the power of a half. This implies that 3 to the power of x is equal to, okay, so we have a power raised to a power, which is the same as the product of the individual powers or exponents. So this is the same as 3 raised to the power of 3 times a half is 3 halves. And what does this imply? Well, if this is equal to this, the two bases are the same, so the x must be equal to 3 halves. So x must be equal to 3 halves. And therefore, we now know that log of the square root of 27 to the base 3 must be equal to 3 over 2. Okay? Let's do another example. Okay? Let's say, for argument's sake, that we have, let's say, example E2. And what we'd like to do is we'd like to evaluate, let's say, the log of, let's say 125, the fifth root. Okay, so let's say the fifth root. Okay, maybe I'll write it down again a little bit bigger. Okay, my marker tip. We'd like to evaluate the log of the fifth root. Okay, of 125 to the base 25. Okay. I'd like to evaluate this. Okay, so let's do it. Let the log of the fifth root of 125, the fifth root of 125 to the base 25, let that equal x. What does that mean? That means 5 to the power of x must be equal to the fifth root of 125. So this implies that 25 to the power of x, the base raised to this power, must be equal to 125, and it's the fifth root of that. Okay. Now, what does the fifth root mean? It means you're raising something to the power of 1/5. So this implies that 25 to the power of x must be equal to 125 raised to the power of a fifth. That's what the fifth root means. Okay. What about 25? Well, 25 as multiple powers of 5 is 5 squared. What about 125? Well, 125 is in powers of 5 is 5 to the power of 3. Okay, so this implies that 5 squared raised to the power of x, because that's what 25 is, it's 5 squared, must be equal to 5 cubed, because that's what 125 is, raised to the power of a fifth, which implies that 5 to the power of 2x, okay, exponentiated, okay, a power raised to a power is the same as the product of the powers, must be equal to, once again, a power raised to a power is the same as the product of the powers, must be equal to 5 to the 3/5. Okay, 3 times a fifth is 3/5. This is equal to this, the bases are the same, so the powers or the exponents must be equal. So this implies that 2x must be equal to 3/5, which implies that x must be equal to 3/10, and therefore we have that log of 125 to the base, the fifth root of 125, the log of the fifth root of 125 to the base 25 must be equal to 3/10, okay, as required. Okay, guys, this was a little bit more complicated, this particular example here, but you can sort of see hopefully the essence of these particular evaluations. We're always trying to evaluate things down. Okay, we're trying to get common bases. We're looking for common powers, and then we let the exponents equal each other, which gives us our solutions. In some cases, this isn't possible to do, and what we have to do is we have to approximate. Okay, but in my next series of videos, you'll actually see how we can do that using a calculator. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland. And I hope that this short video was in some way intuitive, and more importantly, I hope that was helpful for you. And thanks for watching. Okay, bye bye.